we shall start our discussion of the basics of accounting starting from units 7 to 12. Today we will be starting our discussion of section B consisting of units 1 to 6 as per the syllabus of IIBF, which is in respect of business mathematics. It contains topics such as calculation of interest, then capital budgeting, foreign exchange arithmetic, depreciation accounting, etc. So, first of all, we will start with what is known as calculation of interest, and in this we will consider mainly the following important points. One is the time value of money, second is simple interest, then compound interest, then equated monthly installment, normally known as EMI, then the present value and future values of the cash flows, then annuity, then perpetuity, then techniques of discounting and techniques of compounding. So, let us start with the main point, that is known as time value of money. As you are all aware, money has got time value. That means money which is got a certain value as on date will not have the same value as we go along. You must all have known that a rupee today is not the worth rupee tomorrow or a year hence. So, that is why they say a rupee in hand is worth better than a rupee which you are going to receive in future. What is the reason for this? Why does the value change? Value changes because of two reasons. One is what we call the opportunity cost. Opportunity cost is nothing but the cost of the next best opportunity forgone. That means if the money is there, you could have used that money for some other purpose, and the return which you are going to get from that particular opportunity is lost to you because you are using the money elsewhere. So, that is called opportunity cost. Because of this opportunity cost, money has got time value. That means if the money had been invested, let us say in a bank deposit, you would have earned, let us say, interest of 8%. That means your 100 rupees would become 108 rupees after 1 year. But since you are investing this money elsewhere, you are foregoing that 8 rupees, and therefore that becomes the opportunity cost. And second reason is, of course, the inflation. As you know, in the economy there will always be inflation. That means the rupee or the currency will lose its value as the time progresses because of inflation, and because of that the money has got time value. That means because the purchasing power of the rupee or the currency keeps going down as time passes, the value also keeps on changing. And third is, of course, the risk factor is there. Any decision of use of money involves risk. So, and this risk can be both financial and non-financial, and because of this risk, certain return is expected from the unit of currency. Therefore, because of these three reasons, that is the opportunity cost, the inflation and the risk, money has got time value. And therefore, when money has got time value, you cannot add monies coming to you at different points of time together, because they have different values. For example, if you have got a cash flow of 100 rupees today and after 1 year, you cannot call it a cash flow of 200 rupees, because today's 100 rupees is not the same as tomorrow's 100 rupee or 100 rupee which you are going to receive after 1 year. So, in order to add them or subtract them, you need to convert them into the same units. That means they have to be brought to a particular value. Either you bring the value of 100 rupees which you are receiving after 1 year to today's value, or take today's 100 rupees which you have to the value after 1 year, and then you can add. So, that value after 1 year is known as the future value of the currency or the money, and the today's value, as we call it, is known as the present value of the money. Therefore, we are introducing two concepts here. One is called the present value, second is called the future value. Present value is nothing but the value of the money as on date. Future value is the value of the money as on a future date. And in order to find out as to how to calculate future value given a present value, or to calculate present value given future value, we need to understand the concept of interest. So, let us start with what is known as simple interest. Simple interest, all of you must have studied during your school days. Simple interest is nothing but interest which you will be getting on a certain sum of money at the end of a certain period, which is called the rate of interest for that period. For example, if P is the principal which you have invested and I is the simple interest amount which you are going to get after a certain period, and T is the number of years and I is the rate of interest, then the equation for getting the amount which you will be getting after a certain period is given by A is equal to P plus PIT or P into 1 plus IT, where PIT denotes the interest which you are getting on the principal. So, to the principal you again add that interest. Therefore, we have P plus PIT. In many of the textbooks, PIT also may be shown as PNR upon 100. So, where N is the number of years equivalent to T which we are using here, I is the rate of interest equivalent to R by 100. Normally, when 100 is not taken, then I always denotes rate of interest in decimals. For example, if it is 8% rate of interest, I here will be 0.08. If it is 12% interest, I will be 0.12. Or if you want to take it as 12, then you have to divide it by 100. So, this has to be remembered. So, whenever an example is given, if you take it as PNR upon 100, there R becomes the rate of interest in percentage. If you take it as PIT, then I becomes the rate of interest in decimals. So, in the case of simple interest, what you are getting is interest at the end of a particular period, and since you are getting it at the end of the period, there will not be any reinvestment of the interest amount. For example, instead of getting the interest at the end of year, had you got that interest every quarter and reinvested it, you would have got certain thing extra that you do not get in the case of simple interest. For that purpose, we introduce another concept known as compound interest, where interest on the principal which you have invested is again reinvested, so that that interest also starts earning interest. So, there is compounding of interest, interest gets compounded, and this is given by the formula AN is equal to P into 1 plus I raised to N. AN is the amount receivable after N periods. Normally, periods could be number of years, or it could be number of half years, or could be number of quarters, or even number of months, or even number of days, where P is the principal, I is the annual interest rate. Normally, it is R divided by 100 if R is given in percentage terms, or if I is taken, then it has to be taken in decimals. Therefore, what you get is the total amount which you are likely to get at the end of a particular period. So, that includes your principal as well as the compound interest which you have earned on that. So, in order to get only the compound interest, you have to deduct the principal from the amount you have so far got. That is, compound interest will be equivalent to A minus P, that is P into bracket 1 plus I raised to N minus P. So, this is the formula for calculating the compound interest, and therefore, you have to remember that whenever in an example, if you are asked to calculate only compound interest, you have to use the second formula, that is P into 1 plus I raised to N minus P. If you are asked to find out what is the amount you are likely to get at the end of that accounting period, then you have to use the formula, first formula, that is A is equal to P into 1 plus I raised to N. So, here what we have introduced is compounding for any periods. So, if the compounding is done, let us say annually, in that case N will become the number of years, because compounding is done annually. I will become the rate of interest per annum. That means, let us take an example. Suppose you have got 100 rupees and the interest is compounded annually. After 2 years, what will be the amount you will be likely to get? So, it will be calculated by using the same formula. A is equal to P into 1 plus I raised to N, where P is 100. So, it will be 100 into 1 plus I. Let I be 0.1, that is 10%. So, it will be 1 plus 0.10, that is 1.1 raised to N. N will be number of years here. If it is after 1 year, you have to take it as 1.1 raised to 1. If it is 2 years, you have to take it as 1.1 raised to 2, and so on, depending on the given N. Let us say you want to compound it semi-annually, that means every half year you want to get the interest and reinvest that. That means interest you will be getting compounded at half yearly intervals, also called semi-annual intervals. Here, suppose you want to know what is the amount you are likely to get after 2 years. So, n will be what here? N will be 4 year, because in 2 years you will have 4 half years. Since you are compounding half yearly, n will become 4, whereas I rate of interest will be rate of interest per annum divided by 2, because you have to take interest for half year only. So, I will become R divided by 2, where R is the rate of interest per annum. And similarly, if it is quarterly, n will become the number of quarters. So, you have to multiply the number of years with 4. So, 4 into number of years will become the total number of periods, whereas I will become R divided by 4, where R is the rate of interest per annum, and so on. So, it can be theoretically compounded even on a daily basis, where n will become number of years into 365, so many days will be there, where I will become rate of interest divided by 365 days, because R is the rate of interest per annum. And even you can go even further down, saying that it can be compounded second to second, that means continuous compounding it is called, but we are not going into that. For your purpose, normally what the examples we will be taking up will include compounding maybe at monthly intervals, quarterly intervals, semi-annual intervals, and annual intervals. That means only 4 will be taken up by us. And normally all of you bankers are aware of another concept known as equated monthly installment. What is the meaning of this? Whenever a loan is given, the borrower would like to know as to how much he has to pay, so that the end of the certain period he would have paid the entire principal which he has borrowed along with interest, and where interest is calculated on a reducing balance method. So, in order to calculate this, we have to calculate it by using the formula for EMI. That formula is given by EMI is equal to principal into R, P into R, into another bracket 1 plus R raised to n. The entire thing is divided by 1 plus R raised to n minus 1. So, where n is the number of times compounding is done in a year. So, if compounding is done quarterly, then n should be taken as 4 per year. If there are 5 years, then it will be n will be 20. Normally, in the case of banks, compounding is done at monthly intervals. That means interest is applied to the borrower's account every month, and on that again he needs to pay interest. Therefore, it is called monthly compounding, in which case we have to always take n as number of years into 12, whereas the rate of interest to be taken is for a month, that is the annual rate divided by 12. Then we will come to the concept of present value. As we discussed earlier, time value of money is considered while calculating the present value, because money has got time value. We need to bring all values to the present value, so that the monies which we are receiving or which we are expending can be added, because that is the rule in the case of addition. Only like things can be added or subtracted, and therefore, if money has to be added or subtracted, that is cash flows have to be added or subtracted, they have to be converted to the same denomination. That means, if you want to add cash flows occurring at different points in time, you have to convert them to values as on a particular date. Therefore, if you are getting cash flows at a future date, you need to convert them to present values. So, for that purpose, let us define what is the meaning of present value, and then find out how present value can be calculated given the future value of the cash flows. So, PV or present value is defined as the sum of money that is required to be invested now at a certain rate compounded over a number of time periods to yield the desired sum. That means, if let us say if you want 1100 at the end of 2 years, you want to know what is the amount of money which you would like to invest today, so that at the end of 2 years you will be getting 1100 rupees at a certain rate of interest. Given the rate of interest and the amount, you would like to know as to how much should be the amount today. So, the formula will be given by Pn, PV is equal to An divided by 1 plus I raised to n. So, this is based on the same formula which we use for compounding. As you remember, in the case of compounding, we got An, that is the amount at the end of 2 years, by multiplying with the principal by a factor called 1 plus I raised to n. So, there we used An is equal to P into 1 plus I raised to n. So, if you remove P to one side, then it becomes P is equal to An divided by 1 plus I raised to n. P is nothing but the present value. So, instead of calling it principal, we are now calling it present value of the sum of money. So, therefore, it becomes P is equal to An divided by 1 plus I raised to n. It can be further bifurcated. The right hand side can be bifurcated into two. One is An, the other factor is called 1 upon 1 plus I raised to n. An is what? An is the amount of money which you are likely to get in future. So, that is termed as the future value of money, and 1 divided by 1 plus I raised to n is known as the discounting factor. So, if you are able to multiply the future value of money with the discounting factor, you arrive at what is known as the present value. So, what you have to remember is present value is given by multiplication of the future value of money with the corresponding discounting factor. Corresponding discounting factor will be equivalent to 1 divided by 1 plus I raised to n, where I is the given rate of interest, n is the number of periods, and depending on the periodicity of compounding, n and I will change. If the periodicity is annual, then I will be rate of interest per annum, n will be the number of years. If periodicity is, let us say, monthly, then n will be 12 into the number of years, whereas I will be rate of interest per annum divided by 12. That is how you have to calculate. So, here we are using the concept of compound interest to arrive at the formula for the present value. And in order to make life easier for everybody, instead of trying to find out what is a compounding factor, that is 1 divided by 1 plus I raised to n, they have come out with what are known as present value tables. So, there they give the discounting factor for given I and n, and such tables are known as present value interest factor tables. So, using those tables, we can get the value of the compounding factor, discounting factor for given I and n, and multiply it with the future value to arrive at the present value. So, present value can also be put as present value is equal to future value into the corresponding present value interest factor number, that is given in the table for given I and n. Now, we will go to another concept known as annuity. All of you must have come across this annuity. Normally, annuity is used in many situations. For example, if you are paying rent regularly of a particular amount, that means same amount of money is being given out every month to the landlord. So, that is called an annuity payment. Similarly, if you have got an LIC policy or a life insurance policy, you would be paying premium of a particular sum which is paid over a period of a number of years. So, the same amount at periodic intervals you are making. So, annuity is nothing but a series of payments of the same amount spread over a number of periods. It could be in terms of cash inflows, or it could be in terms of cash outflows. Cash outflows are money given out, money going out of the entity, whereas cash inflows are money coming into the entity. So, what are examples of money coming into the entity? For example, pension payments. Whenever you receive pension, you receive a certain amount every month for a number of years as long as you are alive. So, this is an example of annuity. Similarly, if you have opened a recurring deposit account in a bank, you would be depositing, let us say, 1000 rupees every month for the next 60 months. So, this is another example of annuity payments. So, in real life, we have any number of situations where annuity payments or annuity receipts are involved. So, both are treated as annuity. Here again a distinction is made between two kinds of annuities. One is called an annuity due, then another is called an annuity ordinary. So, normally if payments are made at the beginning of each period, that means you are making the payment in advance such annuities are known as annuity due. For example, rent payment. Normally, rent is paid at the beginning of the month. Similarly, life insurance premium is paid at the beginning of the year. So, these are called annuity due. But if they are given at the end of the period, after a certain number of after a period, then they are known as annuity ordinary. So, annuity can be divided into two categories, annuity due and annuity ordinary. So, here the formula for calculating annuity is given by this A n I, that means for given n and I, that is n is given, the number of periods is given, the rate of interest is given, is equal to P into bracket 1 plus I raised to n minus 1 whole divided by I. This is the formula for calculating annuity. So, here P is the periodic amount payment which you are making or periodic receipt which you are receiving, n is the number of periods, I is the rate of interest in percentage divided by 100. And if the compounding is changed, then again I and n will keep on changing. So, therefore, n we always call it the number of periods, depending on the periodicity of compounding. N could be number of years or could be number of half years or number of quarters and so on.